For doing the FD safety setting, we need to first learn a few things, that is static draft, dynamic draft, squat, CATZOC, and UKC, which will make it easy to understand the safety settings later on the FDs. Static draft. Static draft is the vertical distance between the waterline and the lowest position of the hull. What is dynamic draft? Dynamic draft is basically, anything when the vessel is moving, that is dynamic. So it is the static draft plus what happens when the vessel is moving, squat. So static draft plus squat is known as the dynamic draft. Now, what is squat? Vessel's bodily sinkage, which results in reduction in the rudder clearance. It depends upon available water depth. Shallower is the water, the higher will be the squat. And secondly, the speed of the vessel, which is speed is higher, the UKC will be smaller. Why? Because squat will be more. Okay. So yeah, UKC will be down, but here we are not discussing UKC, so that's why squat. What is the shallow water or the confined water? In confined water, the squat will be more, vessel will be experiencing more squat. And if the vessel of speed is higher, she'll be again experiencing more squat. Shallow water, as such, shallow water has not been defined anywhere, but we can take it as 1.5 times the deepest draft of the vessel. That will be the shallow for your vessel. How is squat calculated? Squat is calculated by block coefficient into the velocity square upon 100 in open water, and the same thing twice. It becomes twice in confined water. Block coefficient is obtained from the hydrostatic tables. For each and every draft, the block coefficient is given in the hydrostatic table. Now, for example, in a particular passage, you're going and you want to reduce the squat, the vessel is experiencing squat, what you will do for safety purposes. Uh, One thing that you can do is reduce the speed of the vessel. And the second thing that you can do is change the time of the passage through that area of for the passing while considering the height of tide. Why? Because the more height of tide is there, there will be more water underneath the vessel, and then the vessel will squat a little bit less as compared to when there was lesser water. If the water is less, the effect of squat is more pronounced. If the water is more, the effect of squat is less comparably. Now, CATZOC. What is CATZOC? CATZOC being asked in exam. Category of zone of confidence. Category of zone of confidence. It describes the accuracy and the reliability of the hydrographic data of our EDIS charts. And it also gives the applicable error, because if there is a question about the reliability and the accuracy, for sure there is an error. We also need to measure that error. So that's the accuracy, reliability of the hydrographic data, and it gives information about the applicable error. Accuracy, what things we get from CATZOC? CATZOC basically gives us the three information. It gives us information about the accuracy of position of that particular place, accuracy of calculation of depth of that particular place, and the seafloor coverage. CATZOC has got six varieties or six level. They have been divided into A1, A2, B, C, D, and U. Now, A1 is if we see something like, it is like CATZOC. It is like this kind of triangle. Once you activate on the axis, 1, 2, 3, 4, 5, 6. This will be A1 CATZOC. With for A1 CATZOC, the accuracy of position is plus minus 5 meter, and the depth accuracy is 1 meter plus 10% of the depth. So that means position accuracy, if the position of that particular place has been given as like this 18 meter, this 18 meter will not be exactly, it is possible to, like, in a radius of 5 meter, it can be here, 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 anywhere. And secondly, for the depth, for it is The depth, it is given 1 meter plus 10%. So uh, it is given 18 meter into 10%, 0.10 will be what? 1.8 plus this 1 meter, that is equal to 2.8. The range of depth correction is up till 2.8 meters over here. It can be 18 plus 2.8 or 18 minus 2.8. So like this, for A1 there will be 6 stars, A2 there will be 5 star, for B 4, 3, 2, and then it is unspecified. Now, UKC policy. UKC policy depends from company to company. Every company has got their own policy, and many time it also depends upon the if the vessel company has got varied kind of vessels. It can be operational dependent UKC policy vessel engaged in this kind of operation will have maintain this kind of UKC vessel engaged in this operation will have some different UKC policy, and it can also be dependent upon the kind of area. For example, in offshore, the vessels which are in offshore field are supposed to make have different UKC policy, while inside offshore field, mostly at an average, we can consider like UKC policy as like being 10% of the max static draft or 1 meter, whichever is greater. They can either have just 10 meter of the max static draft or 20% of the max static draft. Like for example, in my last company, we had 10% of the max static draft or 1 meter, whichever is greater. Plus, we also need to add additional 2 meter vertical clearance. And this we were calling as the pipeline allowance because in offshore area, they have many times the pipeline which can go up till 2 meter above the seabed. So that was extra clearance. Like this, you have the UKC policy, or they might also give you some considerations to calculate the underkeel clearance required at any time. This will be the depth of from the chart you will have. In that, you will have to apply the CATZOC depth inaccuracy factor, which we had calculated before, which for every CATZOC variety, there is 1 plus 10% or 2 meter plus 5% or 10%, something like this. We need to check. So that CATZOC depth and accuracy also we need to account for. Then we need to account for height of tide. We need to account for the draft of the uh, vessel, whatever is the draft, and we also need to account for the score of the vessel. The UKC is obtained.